Good morning, and thank you for taking part in Southern Gas Association's Natural Gas Take Action Month, and for attending today's webinar, How Digital Flare Mitigation Benefits the Environment and Oil and Gas Operators. We hope that everyone is safe and healthy during this unique time, and we appreciate your commitment to partnering with us to help change the narrative around natural gas. The purpose of federal and state antitrust statutes is to assure the preservation of a free and competitive economy. To achieve this end, these laws embody a general prohibition against any agreement or combination among competitors which has the effect of unreasonably restraining trade. It is the policy of SGA to conduct its activities in strict compliance with all applicable federal and state antitrust laws and to avoid any appearance of impropriety. Please note that we've muted all attendees upon arrival today to reduce the background noise, since we acknowledge that most of our audience is still currently working from home. As you all know, we're currently relying even more and more on the technology of webinars. Technology is great, but in the rare event that you lose connection, do not worry. SGA is recording today's webinar, and a link to the recording will be sent out within the next few days. If at any point throughout the presentation you have a question for one of our speakers, you can send your question or comments through the questions option found on your webinar control panel. I'd now like to take a few moments to introduce our speakers, Cully Cavness and Hari Savadas. Cully is an energy industry professional with a passion for innovative environmental solutions. He was formerly Vice President of Finance at Highlands Natural Resources, a private equity-sponsored exploration and production company with operations in Colorado and Montana. While at Highlands, Cully's role included responsibility for commodities, sales, and marketing, which exposed him to the industry's challenges with flaring. Cully was previously an oil and gas investment banker at Petrie Partners, a boutique finance firm, servicing upstream and midstream clients. Before that, Cully worked in technical business development roles in the geothermal power generation industry domestically and internationally. Cully holds an undergraduate degree in geology from Middlebury, an MBA from Oxford, and completed a Thomas J. Watson Fellowship researching the Triangle of Ease, energy, environment, and economics, principally in China, Iceland, Spain, and Argentina. Cully is an avid endurance athlete and has completed various ultra-long distance events, including Ironman, Zurich, North Face Endurance Challenge, and the Death Race. I'd also like to introduce Hari Savadas. Hari is the sales director for Waukesha New Engine Sales for North America. Hari has been with the business for 7 years in a variety of sales, business development, and marketing roles. Prior to this, he also spent time at Caterpillar and in other consulting roles in the energy and transportation sectors. Thank you, gentlemen. And now I'd like to go ahead and turn it over to Cully.
Well, thank you. That was quite an introduction. I'm not sure anyone's ever read my full bio like that before, but I really appreciate it. And thank you to SGA and the whole staff there who's really organized this event and helped us kind of prepare and get familiar with all the presentation systems that they're using today. It looks like it's all going smoothly so far, but really appreciate the sort of prep that went into this. My name is Cully Cavness, and I am the president and one of the co-founders of Crusoe Energy Systems. And at Crusoe, what our mission is to find a new and better way to reduce the challenge of natural gas flaring in the oil industry. And the issue of flaring is something that has been in the headlines a lot recently. I think a lot of producers, upstream producers, are familiar with this, but other people throughout the oil and gas industry maybe less so. And so, wanted to kind of start off by explaining what the issue is and getting everybody to a certain base level of understanding. Before we dive into that, just to kind of frame the conversation, this is what you're looking at here on the screen is one of Crusoe's digital flare mitigation systems. And at a high level, what we do is we bring mobile modular data centers directly to the wellhead where natural gas is being flared or wasted. And we use that wasted gas to power generators, which are the large sort of olive colored containerized structures in the center of the screen here. That's a generator that's using natural gas as fuel. And the power coming out of that generator is powering these mobile modular data centers here on the left. So it's one generator here, and 2 data centers on the left, and actually that same module is repeated on the right. So there are 4 data centers in this photo and 2 containerized power generation systems. And so at this site, which is in North Dakota, where there was previously 600,000 cubic feet of natural gas being burned in the air every day as a wasted byproduct of oil production, that gas is now being used beneficially to power energy-intensive computing. And so we'll share a lot more about how this system works, but I just wanted to kind of give a visual of what we're going to be talking about today. And we call this digital flare mitigation. But to kind of frame the conversation for people who may not be familiar with flaring, natural gas flaring is a phenomenon that occurs globally, really everywhere that oil is produced, but there is not sufficient natural gas takeaway infrastructure. There you can find flaring. And to frame the quantities here, on a global basis, we flare about 5 TCF of gas each year. And that's more gas than economies like Germany or Japan use beneficially. So it's just an enormous amount of natural gas going to waste. And within the United States specifically, we have more than 3,000 flares. Typically, a flaring well is a well that was drilled targeting the economics of oil. So the operator is really looking for liquids-based economics, and the gas is a byproduct of the oil production. This is really common in the modern shale industry. And in a situation where there is not gas takeaway infrastructure like pipeline, or maybe that infrastructure is at maximum capacity, so the max pressure has been reached, and it just cannot accept any more natural gas. In those kinds of situations, or situations where it's just uneconomic or logistically not feasible to build natural gas takeaway infrastructure like pipelines, the operator has traditionally not had many options other than just lighting the gas on fire in order to mitigate the safety issue of vented natural gas, and also the environmental implications of venting pure natural gas. So it's better than venting, but it has certainly become one of the environmental black eyes of the oil and gas industry, and something that's just been in the headlines a lot. And frankly, operators want to do something better than flaring, but the solutions need to be economic. And that's really the approach that Crusoe took, is if you want a scalable environmental solution, it really needs to pay for itself and preferably benefit the operator. And then it's very easy to find adoption with that kind of solution. Otherwise, there's a really difficult challenge between the operator, improving their environmental performance, but basically sacrificing economics, which is obviously a really challenging problem for operators, especially in a market environment like today, where things have become so challenging. So this is to frame it up with a little bit of data about the flaring challenge. In the United States, the majority of the flaring that we're going to be talking about today, it occurs in the Bakken, which is Montana and North Dakota, and the Permian Basin, which is Texas, West Texas, and New Mexico. And there is flaring in other states, Colorado, Wyoming, Oklahoma to some extent, and others. But the majority of the flaring is in those 2 oil-weighted shale plays, the Bakken and the Permian Basin. So the digital flare mitigation solution is what we've developed at Crusoe Energy Systems. The story of Crusoe is we're still a young company. We were founded in 2018, and we've grown to 41 people. We've deployed more than 30 of these mobile modular data centers that you see here on the screen today. I'll kind of talk through some of the key points, but then also I'd like to pause here and share the story of Crusoe a little bit to give people context. So again, the high-level objective is to help operators solve the regulatory and environmental challenge of stranded flaring natural gas. So on the left here is a photo of a flare, a photo that I took in the Bakken, and it was just adjacent to one of the projects that we deployed with a different operator. And so you can see why people have a concern. I mean, this is a tornado of fire and a large wasted resource and a lot of unnecessary emissions. And so for sort of obvious reasons, different states have taken different regulatory approaches, but it's disincentivized basically across the board. And if there isn't a regulation against it in some states, then there certainly is growing investor pressure and just public opinion pressure to try to do anything other than flaring the natural gas. And our solution is to capture that gas and generate power and power mobile modular computing. And so that's what you see on the right. That gas that was being wasted is now being converted into beneficial computing. And as a result, we have sort of a different way to monetize the gas that does not require the construction of elaborate or expensive infrastructure like pipelines or other power lines, any kind of physical, long-term, difficult and expensive infrastructure. Because our solution is modular and mobile, it's delivered directly to the well site, and it can also be temporary. We can remove modules as the gas flow rates decline, and we can scale the deployment to match the supply of gas that the operator is struggling with from a stranded gas flaring perspective. This also makes, because there's so little capital investment in terms of from the operator, we really require zero in terms of upfront capital, and generally zero in terms of long-term operating costs. So it truly is a free solution for flaring to the operator, and that makes it the most cost-effective on-site solution for natural gas flaring. It's very fast to deploy. We can deploy a system in about a week, less than a week in many cases now. It's highly scalable from tens of thousands of cubic feet per day to millions of cubic feet per day. We've implemented projects across that entire size range. And it's very reliable because really it's the generator is the only mechanical moving part here. The rest of it is computers, and there are thousands of computers at our deployments. And so even if one was to fail, it's really not even noticed in terms of moving the needle on the power demand side. So it's very redundant and reliable on the demand side, and the power generation side is a generator, which is a technology that's familiar to almost all oil field operators. And there are thousands of those deployed throughout the American oil field. Before going to the next slides, which is a quick summary of some of the use cases that we've seen, just wanted to give a little story of where Crusoe came from. In my background is originally in geology and then in finance, the finance side of oil and gas, and before that, renewable energy. And so I had a sort of environmental thought process and lens for energy, but was working, very deeply within the oil and gas industry as an investment banker, and then as a vice president of finance for an exploration and production firm. And we were exploring in Colorado in our Niobrara shale here. We were drilling 2-mile horizontal wells, and we were very far to the south of the core of the activity. And it was viewed as essentially an exploration or a step out opportunity. And we discovered some very commercial oil wells, but there was no natural gas infrastructure in that area. And so we were flaring some of the natural gas. And, part of my responsibility was to try to find any solution or alternative to natural gas flaring. And it was just really a challenge. And ultimately, we had to build a pipeline to gather that gas to a conventional offtake. And along the way, we experimented with a variety of on-pad solutions, things that were cryogenic processes to chill the gas and pull out some of the heavier liquids like propane or butane and send those to market by truck. Along the way, the oil was all being marketed with trucks, but gas, being a gas, is very hard to capture and put into a truck and monetize that way. So that's the solution that's the situation that most operators find themselves in is an inability to take the gas off site, and so then they end up flaring. So I kind of lived through this problem firsthand as an operator and struggled to solve it, didn't find any great solutions. And so after that experience, wanted to kind of get creative about what could be done other than flaring the gas, and put my head together with a high school friend. We both grew up here in Denver, Colorado, which is where I am now. And he had gone deep down the rabbit hole on technology, especially energy intensive computing, things like blockchain, artificial intelligence, rendering. And there are a variety of computing processes in today's amazing world that are continuous and highly energy intensive, where the cost of electricity is a major driving factor of the economics and the viability of that computing project. And so we realized that really one problem could solve the other. The excess stranded energy in a flare is a very good solution for computing processes looking for abundant low-cost energy. And by putting those together, one problem could solve the other. And so we developed these mobile modular data centers and a whole business model and operating model around solving flaring with computing. So the use cases have been really fascinating, and some of the operators have surprised us with how they want to use digital flare mitigation. Again, being a geologist, my first thought was exploration and delineation wells. So this is for an exploration company that maybe wants to poke some holes around the margins of their asset to see what's down there and to extend the what's viewed as their core of their asset by proving up the margins and extending what's viewed as economically viable. And so typically in that environment, there's not going to be a pipeline there because there hasn't been a lot of activity. So there's been nothing to justify the construction of a pipeline. So with digital flare mitigation, a producer can drill that exploration well, no matter if it's 1 mile from the pipeline or 100 miles from the pipeline, and we can arrive on site with our mobile modular offtake solution, and any gas that comes out of that discovery, we can take that and mitigate the flaring through computing without having to build the pipeline. And then as there's enough drilling activity that eventually justifies the construction of infrastructure, the pipe will arrive. And there's sort of that leapfrogging effect of using digital flare mitigation first, and then building the traditional infrastructure, and then again exploring the next margin, and then again building the pipeline infrastructure. Especially in North Dakota, we've seen that a lot of operators have some pretty significant right-of-way issues where they've taken the view that on some of these assets, they may never get the rights to build the pipeline. And in that case, what do they do with the existing wells that are on flare? And some of these wells have been flaring for a long time. I mean, there are parts of these assets that have been flaring for 5 or 10 years because they've never had any sufficient pipeline takeaway access in those assets. So we can finally come in and really knock out that flaring again with digital flare mitigation deployments. So those are sort of the leading edge solutions and use cases. There's also a system constraints use case where maybe the asset is tied into infrastructure, but there's a bottleneck either because of the capacity of the compression units. Maybe it's a capacity downstream at the processing plant. Maybe the operator wants to defer some capital investment and isn't ready to build out that next stage of compression to increase the capacity of the pipeline. We can help defer that CapEx by alleviating the upstream volumes that were trying to get into the pipe but just couldn't because of a pressure problem. Now we can basically come in and solve that with on-site, on-pad takeaway through digital flare mitigation. And interestingly, in North Dakota, the majority of the natural gas that gets flared, it is connected to natural gas pipelines. It's just that historically, those pipelines have had some form of bottleneck or capacity constraint downstream, be it compression or processing plant outages or things along those lines. And so this is one that really resonates, especially in the Bakken, in that North Dakota, Montana area. And then there is actually a use case at the processing plant itself. So for example, in North Dakota, there's an ongoing debate about whether one of the main trunk lines out of the Bakken, which goes over towards Chicago, whether they're going to change one of the specifications on the BTU content of that gas. And if that change occurs, it could cause some of the operators of plants, gas processing plants in the Bakken, to need to reject more ethane out of the gas stream, which is a technical issue, but basically that's a big operational change, and there's not a really easy solution for them in that outcome. And one of the interesting cases here is that we could actually come into the plant environment and take some of that rejected gas that was going to go to flare or some other kind of waste outcome, and we could actually use that for beneficial use by doing digital flare mitigation at the plant itself. That also could apply to a situation where there isn't sufficient offtake for the rich gas stream or for the lean gas stream after it's processed. For example, in some cases, the processing plant is really making most of its economics by selling natural gas liquids that have been processed out of the gas stream. And so there might be more appetite for natural gas liquids, but there's no more takeaway capacity for the lean residue gas. And so if they could have a better offtake for the residue gas, they could process more natural gas liquids. In those kinds of interesting use cases, we might be a solution. We haven't worked with a processing plant yet, but we're pretty sure we feel like there's something here that we can help essentially improve the environmental performance and the economics of natural gas processing by bringing in some of our incremental capacity to some of those waste gas streams or spec change situations or takeaway limited situations. So we talked through a few of the use cases, from the leading edge to capacity constraints to the plant level. The majority of our deployments have been in that leading edge or capacity constraint environment, the first two use cases. And so a couple of photos here, you can see that we've deployed in hot climates and in cold climates. North Dakota is famously very, very cold. You know, we're now getting into winter here, and you can have long periods of time in the -degree Fahrenheit zone. It's pretty shocking if you're not used to it, but we've been able to winterize and harden our packages and design around the rugged oil field conditions that we know we're going to find. And so for 2 years, you know, summers and winters and a couple of cycles of those, we've been able to continue to refine our designs. We're onto our 4th generation of the data centers now. But some things you can see here, it is fully modular and mobile. So these things are delivered as shipping containerized data centers that fold open, and inside all of the heating, ventilation, cooling, networking, electrical, air filtration, obviously the infrastructure of the shelving and the way that we're going to contain the servers, all that's pre-designed in, and it's designed to just fold open and bolt together in a day, essentially. And we can do this with roustabout labor that we've trained on our specific process. So oil field labor that knows the safety processes that need to be in place, we've trained them on how to configure and deploy our solutions right on the pad. We also have a similar, rapid startup process in place for the Waukesha generators. Hari's going to share a little bit more about the power generation side specifically. He's coming from Waukesha, but we've been really pleased with Waukesha. And by the end of the year, we'll have about 40 megawatts of power generation capacity delivered from Waukesha to our digital flare mitigation sites. All of those are running on wasted gas and powering computing at the wellhead. So the setup is very quick. Many of these processes run in parallel. Essentially, it is a process of manifolding into the existing gas line with roustabout work that is typical of any oil field site, deploying the generator, which comes on a truck, a permitted load, and offloading it with a heavy crane. And then the computing modules are deployed in parallel with the generator typically. And finally, there's a startup process where we commission the generator and the servers, and everything comes up and gets on the network, and then we can monitor remotely with our custom built dashboards and automation systems. So here's a footprint of where we've deployed our units. We've just passed the 30 mark in terms of number of deployed mobile computing units. Most of that is in Montana, North Dakota, again, the Bakken asset. The little Crusoe logos here, the red flare that's being captured, it's our logo. Those are our headquarters or office presence. And so we're headquartered in Denver, Colorado. We have a secondary headquarter, I guess a split headquarters between Denver and San Francisco, which is where we have a really talented software engineering team. And then in North Dakota and Williston, we have a field operations center, which is actually our biggest headcount as a company is up there. And in total, we're about 41 people. About half those people are in the field in North Dakota. We've also deployed units in Colorado and Wyoming. So in total, we've deployed in 4 states, and the basins have been Denver-Julesburg Basin, Powder River Basin, and the Bakken. So here's a footprint showing a potential design for a layout that's about 1 million cubic feet per day in capacity. And so the black boxes here are the Waukesha generators. Each one is a 2,500 horsepower unit that consumes about 300 MCF per day of rich gas. If it was pipeline spec gas, it would be closer to 450 MCF per day. That's 1,000 cubic feet per day. But because we're working mostly in the Bakken, when we see gas in the 1500 BTU range. We know we're getting more BTU per 1,000 cubic feet, and so we size for more about 300 MCF per day per package. And then each generator package feeds a transformer, which steps the voltage down, and then that transformer feeds 2 modular computing units, which are in red here on the screen. So the whole footprint here is very compact, and we actually have ways to make it even more compact with some of our new designs, but it's about 150 feet wide by about 75 feet deep. So any modern shale well, multi-well pad is going to be able to tolerate this on the margin somewhere within the setback requirements. We haven't really had too much difficulty fitting these into the sides of the pad. And if it gets tight, then we can actually reconfigure and make more of an L shape or lay out the units in a slightly different configuration. So one of the most important pieces of Crusoe, and certainly the one that's nearest and dearest to my heart, is that we are delivering a really legitimate environmental benefit and doing it in an economic way where it's not an imposition on the operator. Again, going back to this idea that oil and gas operators want to improve their environmental performance, but they can't do it at the expense of just a massive outlay of capital with no view to return. That's the feedback we hear over and over from operators. We want to find economic solutions that are environmental solutions, but it does need to pay for itself on some level. And so we found a model that is no CapEx, it's generally very low or no OpEx, and it's actually providing some revenue to the operator. We do pay a nominal amount for the gas, and on top of that, they're getting a massive emissions reduction and a reduction in flaring, which helps them comply with all of their goals for environmental targets. Talking about the emissions reductions here, one of the key things to know about flaring is that when gas is being burned, not 100% is being combusted. Actually, a significant percentage escapes to the atmosphere in an uncombusted state. And methane is a very powerful greenhouse gas. It's anywhere from 25 to 80 times more potent than CO2, depending on what time frame you use for the analysis. And so when we look at digital flare mitigation relative to flaring, there's about a 39% reduction in carbon equivalent emissions reductions. And that's because we're just fully combusting the methane. On top of that, we also have the best catalysts that you can specify for these packages, so much so that we could permit one of these units literally next to a hospital. The catalysts and the emission control systems are so high quality. So we're getting a huge reduction in nitrogen oxides, volatile organic compounds, and carbon monoxide. And those are the emissions that typically form smog. So this is really an immediate human health benefit. But in a longer term climate view, there's also a significant CO2 equivalent reduction because we're reducing methane emissions. In addition to digital flare mitigation, in terms of the computing modules we deploy, we also have to deploy really sophisticated networking solutions. And as we've stepped up the ladder from low bandwidth, high latency tolerant forms of computing, where we started, that was with satellite internet, we've worked our way kind of up the ladder of network strength and quality, going to wireless, microwave, and millimeter wave tower constructions, which you can see in this middle photo here. This is a proprietary tower for a private microwave network that we built in the middle of the Bakken oil field in eastern Montana. And we get a gigabit per second from this tower. And so we can deploy all kinds of amazing computing activity at this site, even things that require very, very strong networking. I mean, it's safe to say that that site probably has better internet quality than I have at my house or my office. And then we also have a pretty amazing network of fiber connections, which you can see on the right. And often we deploy these three technologies as a combined hybrid solution. So we might have satellite as a backup or a base case, then we upgrade it with millimeter and microwave, and then tie into fiber. And that whole hybrid gives us a really redundant, high quality, low latency network. You know, talking about the team and the background of the team is something that's really, really important for Crusoe's success. we've got more than 40 people now. We've grown very quickly since just founding in mid to late 2018. And to date, we've had a total recordable injury rate of 0. That's very important for our company to work with the high quality operators that we want to have as clients. And so we've been able to get through the MSA process with multiple publicly traded oil and gas companies, international oil and gas companies, these firms that have the highest level of safety standards. We're also vetted by third-party safety audit groups like ISN and PEC. And our operational leadership team is top-notch. We've recruited people from, companies that you can see their logos at the bottom. Ken Parker has more than 25 years of experience with firms like Pioneer Natural Resources, Williams Companies, British Gas, BG Group. Was leader of a massive project, hundreds of millions of dollars of capex for an LNG installation in Australia. Has experience with pipelines, with upstream facilities. And then the people that are in our field leadership roles are also equally, or if not more, experienced. Debbie Meeks, with more than 35 years of experience around engines, and specifically the Waukesha packages we use. Travis Reinstead is a master electrician with 25 years in the oil field, making sure that all the electrical work is done properly. Nick Corridor comes from a fracking background, so that's a very, very safety-oriented mentality that you need to have. He was at Liberty Oilfield Services, another Colorado-based oil field company, and he helps us manage and ensure safe deployments of new facilities wherever we go in the Bakken or elsewhere. And they're supported by just a really great team. We're proud to have this team, and it's a basis of our success for sure. The leadership team, is also really talented and diverse. We've got people that have come from the technology industry. For example, our CTO, Nitin Parambedi, we actually just recently promoted him from VP of Software Architecture to CTO. He formerly was a CTO at a startup that sold to LinkedIn. Chari Akshay, he built the back end of AngelList, one of the most widely used websites for recruiting in Silicon Valley. Tarab Bajwa has a CPA and an MBA from Stanford, and is just a very, very talented member of our finance team. And he works closely with our CFO, Matt Deneza, who was the CFO of Eclipse Resources and took them public and was their CFO for 6 years. Before that, he was at Deutsche Bank as an investment banker for more than 14 years. Ken Parker and the operations team we've discussed a little bit already. And then Andrew Likens, our VP of Business Development, he comes from a land background and was a land manager at Camino Natural Resources, where they deployed more than $1 billion in the Scoop Stack and became the largest private acreage holder in that shale play at a time when it was sort of the hottest play in the shale industry. So it's a very interesting hybrid of San Francisco Bay Area tech with traditional oil field roles, and people that we've been able to merge into a really unique culture at the company. Speaking briefly about our capital, and we think it's important for our clients to know that we're here to stay. This is not a thinly capitalized startup from San Francisco that's giving it a shot. At this point, we've raised more than $100 million, and we've got some of the best investors that anyone could really hope for. We are venture capital funded from San Francisco, and I think this is one of the unique elements of our business that allows us to be so growth oriented and sort of exploration oriented in terms of developing new technologies. Our lead investors have been Bain Capital Ventures, Founders Fund, KCK. We've had the Winklevoss twins have invested significantly in our company. Upper 90 is a mezzanine credit fund out of New York that has developed a very unique, flexible credit type financing for some of our projects because they are quite capital intensive. And then Polychain and Dragonfly Capital, to name a few of the more niche technology focused venture capital firms, digital technology focused venture capital firms. So it's really a hybrid of industrial technology, digital technology, credit investment, and through all of that, we've put together just a really great group of investors and a great board. And kind of wrapping up here from my side, we won't read through it in detail, but just wanted to provide some client testimonials. So EnerPlus being a public company, Kraken, one of the largest private operators in the Bakken, and Thunder Basin Resources is a private equity-backed exploration group in the Powder River Basin. We've got quotes here from VP and CEO level executives at these companies talking about the success that they've had with Crusoe. And we kind of took an early on view that turning flare gas into computing probably is going to sound pretty crazy early on. And when we were just getting started, we were nervous that people would be hesitant to pitch this to their management teams because it just sounded so new and so different. And there's a trepidation around being number one in a conservative industry like the oil and gas business. So we took the view that we need to make the people that are early adopters look really smart and be successful internally. And so we've kind of taken this view we need to go above and beyond and have a very high touch service orientation to these clients. And if there ever is any issue that pops up, we have to solve it and make it right immediately. And more than anything, we want these deployments to go safely and smoothly so everyone can go back to their team and be proud of bringing in a new technology and new innovation. And largely that's been true. I mean, people have been able to tout Crusoe's solutions as a digital transformation story, an ESG story, which has never been more important than it is right now in the oil and gas business for that maintenance of the social license to operate. These kinds of things, we're deploying digital technology to reduce natural gas flaring, to reduce resource waste, and to reduce emissions. That's a great story for any operator. And I think the more that we've been able to prove ourselves to some great companies like the ones on the screen here, the more comfort that other operators have to work with this technology. And so at this point, I'm just going to hand it over to Hari, and he's going to share some of the more detailed information around the Waukesha package and the platform that we've used as one of the backbones for our larger scale deployments at Crusoe.
Yep, thank you, Kali. Hopefully everybody can hear me well. Just to introduce myself again, my name is Hari Savadas. I've been with Waukesha for about 7 years. I'm currently new engine sales for the North American market. So as you folks probably saw, 80% of this presentation is centered around Crusoe. We firmly believe that the unique value proposition is the business model that they bring, and we're just an enabling technology. So I very much appreciate both Kali and the SGA group here giving us an audience to talk a little bit about Waukesha. I think most folks at GMRC, within the GMRC membership, should be very well familiar with Waukesha. We've been a mainstay in the compression industry for over 100 years. So the company very recently was part of General Electric, and about 2 years ago, we got divested out of General Electric and are currently privately held. So just a quick overview, as you can see on this page, of our product line. We span from around 200 kilowatts at the bottom end of the power generation application to right around 3.2 megawatts at the top end. What sets Waukesha apart is our rich burn gas engine technology expertise. We have the broadest portfolio of rich burn engines in the world, including the highest horsepower rich burn engine in the world, the 9394s, which has been used very successfully by Kali and team for the digital flare mitigation application. And what the rich burn technology brings is a couple of key product attributes that's very well suited for this marketplace. One is the ability to burn some very, very high BTU fuels under some very challenging conditions. The combustion technology that we've got lends itself to be able to do that. And we'll get into a little bit more detail in one of the subsequent pages. The second is pretty low greenhouse gas emissions footprint. We're talking sub 600 grams per kilowatt hour of CO2 equivalent footprint versus many other competing engine technologies. We'll get into a little bit more detail again in a subsequent page. And then lastly, I'd say Waukesha has been around for a long time. We've got well north of 15,000, probably approaching 20,000 operating engines globally, a lot in North America and US and Canada, but we're a global provider of compression, mechanical drive, and power generation solutions to our customers around the world. Kali, if you could go to the next page. So just a quick overview on rich burn technology benefits. As I mentioned on the prior page, the key benefit for rich burn, especially for oil field power, is our ability to burn some pretty hot fuels. This page is primarily focused on our VHP product line, which is our bread and butter product line that's also been used by Crusoe. I won't get into all the numbers, but you can see from a fuel flexibility perspective, depending on which engine submodel you choose, we can operate without any sort of power derate due to fuel on some pretty wide-ranging gas qualities. So anywhere from 1250 BTU to about 2300 BTU, we're able to pull full power across a variety of engine models. The second one is wide fuel tolerance, especially in the oil field where fuels can change depending on what wells come on and off, especially on the upstream side. We're able to operate all the way up to about 2350 BTU and associated fuel swings with little to no changes on the engine. So you're talking the ability to almost set and forget the genset in the gas patch. The third one is the ambient and elevation tolerance. The Bakken that Kali mentioned, it can get very cold, and it's also at a slightly higher elevation. We've also got the ability to do this in very hot temperatures. So folks in the Permian, where flaring can also be a challenge, we have the ability to operate up to 120, 130 F Fahrenheit with, again, little to no derate depending on engine model. We've got applications all across the Middle East where the hot ambient tends to be an extremely challenging environment for us to operate in. We've been doing that successfully for decades. The last one, probably most crucially, is the emissions play versus competing engine technologies. The criteria pollutants are on NOx, VOCs, and CO. Because we're a rich burn engine, essentially we're using a very simple three-way catalyst to be able to reduce those emissions. You're talking, end user price in the catalyst that is, well under $30,000 compared to, say, a lean burn engine. As you get to lower and lower NOx emissions and pollutant emissions, you might be forced to use things like a urea SCR, which can be a lot more expensive. The greenhouse gas piece, which is illustrated a little bit more clearly on the right-hand side, this is actually from a real-world engine where we compared a lean burn gas engine to a rich burn engine. We're talking about 30% lower CO2 equivalent. A lot of lean burn engines today, as they push frontiers of efficiency, you do have leaning out of the mixture, potentially incomplete combustion, potentially valve overlaps due to very aggressive Miller cycles that is leading to potential methane slippages from the engine. So what you see is, from a CO2 perspective, although it's pretty close between a rich burn and a lean burn can even be a little more efficient than a rich burn. Once you factor in methane or CO2 equivalent, you'll see a rich burn technology clearly win out. So in this real world example, you're showing a rich burn engine with about 30% lower CO2 equivalent footprint compared to an equivalent lean burn. Next page, Kali. So oil field power that Kali's been talking about. So what's unique about what Crusoe has done is twofold, right? We all know that flaring has been a challenge. It's been a challenge for decades. There's many pockets around the world, not only North America, that is contending with this problem. But it's always suffered from a couple of challenges, right? One is, maybe the lack of political will. There's really no penalty for flaring. There's no regulatory schemes that incentivize people not to flare. So for all the right intentions of policy groups, governments, NGOs, et cetera, it continues to be a problem. The second challenge has been that flares tend to be remote. Oil and gas fields tend to be extremely remote. And so the idea of having a large enough load on site has been an issue. In these remote areas, you're talking maybe a small oil and gas site, maybe it's got a few hundred kilowatts of load. Not every place has got a large processing plant or even a large urban center located next to the oil and gas field. So when you couple those two challenges, it's been really hard to move the needle on flare mitigation around the world. The other angle that Crusoe has helped solve is the concept of distributed computation has been growing exponentially over the past decade or so. It's probably the fastest electrical load growth application, certainly in North America and many other parts of the world. And the challenge there is a lot of times they're looking for the cheapest possible power, and in many cases the cleanest possible power. What Crusoe has been able to do is marry those two applications together, where they can bring these modular distributed computational data centers to the gas patch and solve the load problem that traditional flare sites have had, where they don't have a load. Now you've got this data center that's consuming a lot of gas because those servers are the load that was lacking. And then from a computation standpoint, the fact that you've got all this excess gas, either stranded gas or flared gas, it presents the opportunity to be able to provide these computational providers with some pretty low cost fuel and low cost power. And here what we're showing is, you'll see on the bar chart here, this is the CO2e intensity of the US grid. So obviously it varies depending on which location you're in, but on average it's about 1,000 pounds per megawatt hour. It is absolutely getting cleaner every year as the grid itself decarbonizes with more wind and solar coming online. But today it's roughly about 1,000 pounds per megawatt hour. So what we're showing here is if you've a distributed computational application, instead of drawing power directly from the grid at that CO2 intensity, if you were able to use one of our gen sets as Crusoe's deployed and use available gas in say a stranded field and generate power using that to power your data center, you're offsetting that amount of CO2 equivalent from the grid. So per megawatt, roughly we're showing about a 4,000 tons per year of CO2e reduction by making power using the genset on site as opposed to drawing power from the grid. Next page, Kali. And this is the real proof in the pudding, right? So this is the case study that Kali alluded to. So this is up in the Bakken, oil producing well. There's flaring gas, little to no pipeline connectivity, little to no electrical grid connectivity, very rich gas, about 1,500 BTU. And the solution that we've deployed for Crusoe is about 19 1.8 megawatt rated 9394 VHP gensets, pushing about 35 megawatts and looking to scale up to 40 megawatts and beyond here in the coming months. It's, like I said, there's no grid, so it's 100% of the time operating in island mode. And as you can see from the picture, on the right-hand side, you'll see the genset. On the left-hand side, you'll see these distributed server containers that Kali talked about. And the fact that you're using this cheap gas on site, you're able to provide some very low-cost power to meet those data center energy needs. So for North Dakota specifically, the avoided CO2e from the grid is even higher, given the fact that the North Dakota grid is a little bit dirtier than the average CO2e intensity for the United States. So I'll stop there and maybe turn it over to Kali to kind of wrap up, and we can go into Q&A.
All right, thank you, Hari. Just coming off mute, hopefully everybody can hear me. So just kind of to wrap it up with a few key points, Crusoe has, with the support of Waukesha for our largest scale deployments, we've been able to really scale up a solution that facilitates flare mitigation and regulatory compliance at just about any scale that's required from the modern shale industry. And the benefits that the operator receives from this, it's legitimate third-party or legitimate beneficial use and third-party gas offtake solution without the construction of long-term or expensive infrastructure such as gathering lines. It reduces flaring, waste, and emissions, especially of those smog-forming precursors, NOx, SOx, and VOCs, but also carbon dioxide equivalent. To date, we've mitigated about 1 billion cubic feet of natural gas that would have otherwise been flared. We put it to use for computation, and we're probably going to be making a press release about that milestone here pretty soon. Something we're really excited about is just the scale we've achieved, really very quickly since launching the business. There's been just a strong demand in the marketplace for more and more of these systems, and it's helped us scale up. It's very flexible. It can manage just about any gas volume from the very small to the very large because of the modular nature. And there's no lengthy land acquisition or right-of-way negotiation or pipeline permitting process, which makes it fast to install. And really, it's a flexible, easy to implement solution. It's been done now by many operators, from the largest publicly traded operators to smaller private equity backed or independent operators. And we would love to talk with anybody who has a flaring challenge that they would like to solve. We've got some contact information here for both myself on the Crusoe side and also Hari on the Waukesha power generation side. Of course, if anybody's looking for a generator for any other reason besides flare mitigation, Hari's certainly able to talk with you about that. And I think with that, we're through the meat of our presentation, and would love to open it up for any questions.
Okay, I've got a couple of questions here that came through in the chat, and anybody on is welcome to send theirs in. First question here is, do you have outside customers for the database? I think that was one that you touched on early on in the presentation, Cully.
Sure, yeah. One of the really nice things about the way we've designed our business model is that the oil and gas producer doesn't need to worry about or touch the computation process in any way. So we fully separate that from the oil and gas relationship. So first of all, just to kind of answer the obvious question is, are you going to get a phone call in the middle of the night from a data center customer, who's angry because the well went down and the gas supply went down? The answer there is no. We do a variety of different types of computing. Some of them have very specific customer relationships. Some of them are more in a network fashion. For example, some of the Bitcoin or blockchain related computing, you're really servicing a network rather than an individual customer. So it does depend on the type of computing deployed within the data center. But high level, I think that the important question, if I'm reading between the lines, is that there isn't a compute customer relationship that the oil and gas producer or midstream operator would need to worry about.
Great. Next question, are you creating and monetizing carbon credits through the reduction in emissions?
It can be possible in some situations to achieve carbon credits for these projects. And, we're working through a handful of those situations at the moment. To date, we have not monetized any carbon credits, although it is something that we think could be another feature of these projects going forward, and something we're really researching and hoping to become experts on how to do that. There are some very interesting markets in Europe where this could be applicable. There are voluntary markets in the United States and North America and Europe and elsewhere. There are a handful of different standards, and some of them are more applicable than others, depending on the way the project is configured and what the regulatory environment is in that state. It seems to have a lot of impact on which standard and which pathway you choose for potential carbon credit.
Great. And next question, do your skidded data centers sit idle when they're not deployed?
To date, we've been really fortunate that we have kind of been oversold. So essentially, whenever we take delivery of a new unit, there's a home for it that our business development team has pre-sold, and it goes directly to the field. So, unless it's just kind of waiting for deployment at one of our manufacturing sites, we haven't had many units sitting idle, other than maybe, as one contract ends and we're waiting to redeploy it to the next contract, there might be a little bit of downtime there. But we've been able to keep that process really pretty efficient. So I guess, yes, technically, in theory, it's no problem at all for these to sit idle, but we just, from a business development standpoint, haven't had to do that yet.
Maybe a bit of a follow-up, one question that we've had. How easy is it to transfer data center capacity when a site no longer has flaring?
Yeah, it's a great question. We have seen that. I mean, especially after COVID, what we saw in the Bakken especially was there was this wave of shut-ins, just around that period of time where the oil price went negative, and it felt like the whole world was falling apart, especially in the oil business. A lot of operators reacted to that by shutting in or curtailing production and taking a view very logically that maybe we shouldn't sell this oil at like single-digit dollars per barrel, and we should wait for the price to come back and for the market to stabilize. And so in those cases, obviously our projects were impacted because the gas supply went away. And what we were able to do was exactly that, to remobilize the computing hardware to sites where the gas was still available. And so we've been able to get that process down to just a day or two. So we fold up the data center, we bring in cranes and trucks, we can have it out of there in the morning, and we can actually have it redeployed at a new site in the afternoon. The Waukesha package takes a little bit more time, but still it's within that single-digit days, less than a week time frame to redeploy. And so we've worked through a handful of redeployments, especially around that COVID crisis. It is definitely possible because you can see it in the photos here. They're really skid mounted and containerized, so designed to be portable.
Great. And last question here, maybe one for Cully and a bit for Hari too. So what's a typical contract length for our customer with Crusoe, and then how is that serviced?
Yeah, it's a great question. Typically, we're working on 1 year plus, so most of our contracts are 1 to 3 years right now. We, from a Crusoe perspective, prefer longer. We're definitely happy to stay as long as the client requires, and that helps us, reduce the amount of mobilizations and the expense and downtime associated with that. Some of the contracts do have sort of a early termination clause. We try to keep the financial risk and cost very, very low for the operator and make it sort of a no-brainer commercially, but we do need to know that we can be on site for a certain amount of time. So we agree to that timeline up front, and if things change, there is flexibility in the contract for the operator, but with some expense. And as long as the contract plays out the way that it was originally designed, then it truly is that free solution for flaring. In terms of the way that it's serviced, we do have a field operations team, which is largely comprised of mechanics, electricians, and technicians. Those are based out of Williston, and they essentially rotate throughout the Bakken, servicing our units, keeping everything running very reliably. And what we've seen from a downtime perspective is that the largest source of downtime for us is actually the client gas supply. So we try to work with clients that have a redundant gas supply with multiple wells. That way, if one well has a hole in the tubing or a pump failure, something along those lines, there's still some redundancy and resiliency in the project's gas supply. And we're essentially always on call, and we have a really great team that rotates to maintain and operate our equipment.
And Cully, if I were to add from the Waukesha side, as most large engine manufacturers do, we have our network of service providers or channels around North America, and we have some in the Bakken as well that we're partnering with, that Crusoe and us are partnering with to provide service. And then in addition to Crusoe's own team and our channel service team, our own factory has got service technicians that are available to support and supervise as needed, as sort of a last line of defense for extremely critical problems. So that's been very handy as well. We're also deploying, and this is an interesting tidbit given the San Francisco Bay Area exposure that Crusoe's got with the software development team, our remote monitoring system, and that's something that's come in very handy to keep an eye out on these packages. And Crusoe's team's been certainly pushing the boundaries on our system, and we've been learning a lot from them as well. So it's been a combination of those things that's been keeping these packages running.
Yeah, that's a good point. We didn't talk too much about it, but we've built out on the Crusoe side, a completely custom monitoring and automation dashboard system where we can go in and see all of our units down to the server level. We can control the amount of power demand. We can respond to a declining gas pressure, for example, by changing or adjusting certain of the operations on the computing side or within the generator. And then if we see an issue popping up, it sort of automates a dispatch to get people out to the site as quickly as possible to solve any issues that might pop up. And that's been a big investment and a big sort of technical undertaking on our side, and it integrates really well with the Waukesha solution that Hari mentioned. They've got their own remote monitoring system and data streams, and so putting all that together has been a big part of the integration process.
Thank you, gentlemen, so much. On behalf of SGA and GMRC, I would like to thank both Cully and Hari for speaking to us today. And thank you to all of those of you that attended. We will be sending an email out within the next 48 hours that will include a link to the recording. And we do ask that if you have the opportunity to please join us this upcoming Friday for our final webinar of the Natural Gas Take Action Month. It's the You Are Equipped, Now Be a Natural Gas Champion program. You can register on SGA's website event page. And with that, again, Hari and Cully, thank you so much for speaking to our audience today. We are going to go ahead and conclude today's webinar. Thanks, everyone.
Thank you.
Thanks very much.